The reason why we're doing this experiment is that biofilms create a tremendous problem in many industries, specifically in the energy industry. When biofilms lay down on pipeline infrastructure, for instance, you can set up a very aggressive corrosion mechanism underneath that biofilm. But the fundamental question the industry has always struggled to answer is that corrosion under the biofilm, is it due to the thickness of the biofilm? Is it due to the amount of time that the biofilm sits on the metal surface? Or is it due to the composition of the biofilm in terms of the types of bacteria that are present within the biofilm? And it's very difficult to untangle that here on Earth. You can't separate those variables very easily. So one of the nice things about working on the International Space Station, we can run an experiment on the International Space Station where we know biofilms grow much more quickly and to a much greater thickness than they do on Earth. And so by running the experiment on the International Space Station and at the same time running it on Earth under identical conditions, with the exception of microgravity, we can then untangle or decouple that time element from the thickness element. And by doing that, we can answer that fundamental question. Is it time that's important? Is it the thickness of the biofilm which is important? Or is it the composition of the bacteria that make up that biofilm? Is that the important factor that really influences corrosion underneath biofilms?